let us have 1 or 2 points from this particular concept. Here we are taking the electronic as well as steric effects, both are influencing in such a way that gives the explanation in a better way. This you can term as mixed applications. In these applications, the inductive effect, resonance and the mesomeric effect, hyperconjugation and also steric effect, all these 5, sometimes all the 5 may be we are taking, or sometimes only 1 and 2, 3 and 4 and so on. It is not one single effect, but multiple effects we are taking and judging the why this is going to be formed and so on. One such example is here, the acidity of phenols. We have 3 different examples under this category. The first example, let us take chlorophenols. Chlorophenols. We have 4 such phenols. Let us take ordinary phenol, okay, and a phenol with a ortho substituted orthochlorophenol, and a phenol with metachlorophenol, and the parachlorophenol, right. So, we have 3 chlorophenols, original phenol, let us take A, B, C, D. Now, the acidity, when I compare, all these chlorophenols are stronger than the phenol. This is because of the minus I effect. So, the chlorine pulls, therefore, the single bond is polarized, therefore, this is polarized. So, for this O is also polarized, so that the H comes firstly. So, the H donation we call it as acidic property. So, in such a case in the chlorophenols the inductive effect makes the donation of proton easily, or when once the proton is lost, then what happens is formed a phenoxide anion. This has got originally resonance stability, okay, right. In addition to that, we have a chlorine also. So, chlorine pulls. So, the negative charge on the oxygen will be apparently decreases. So, therefore, the stabilization of the phenoxide anion in the case of chloro substituted is more. Ordinary phenoxide and chloro substituted phenoxide, when you take, this is more stable than the so called the ordinary phenol. So, therefore, the formation will become easy, that means the donation of the proton is easy. Therefore, all the chlorines will have a minus I effect, therefore, increases. So, therefore, in one way you can say the compound B, C and D are stronger than A. This is the statement 1 you can say. And within the B, C, D, here in this particular case, in general, mesomeric effect is real electron transfer, inductive effect is a electron density transfer. So, inductive effect is a weaker one generally, mesomeric effect is a stronger. Resonance or mesomeric effect, even hyperconjugation, they are strong when compared with inductive effect. But in this particular case of the acidity of the phenols, it is taken that minus I is dominating the plus M effect. Actually, the chlorine shows minus I effect through the bond and the electron donation over the bond. So, here minus I is dominating, therefore, we take only minus I and decide the issue, taking the only the minus I, leaving the plus M, because plus M, if it is influencing, plus M has a positional effect. Is that influencing means no. So, therefore, it is understood only that minus I dominating feature in this case is an exceptional case, it is not a general. Minus I generally will be a recessive, mesomeric effect is dominating, but in this particular case we have to take that minus I is dominating. And similarly, generally plus M effect groups are orthopara directing as well as ring activating, but these chlorines are ring deactivating, orthopara directing but ring deactivating. There also we take this another same similar case where minus I dominating over the plus M. In general, mesomeric effect, right. So, in this case, so therefore, B is stronger than C, stronger than D, all three are stronger. So, therefore, overall order is B stronger than C, stronger than D. How you arranging this B, C, D? This is inductive effect. As the distance increases, the effect decreases. So, based on the distance factor, we graded the B, C, D, and A comes at the end. This is what the data of the acidity, if you check, it is resembling. So, therefore, we are able to explain. So, the B compound A is weak because there is no chlorine. In the BCD, chlorine is closer, little far away, little far away. So, inductive effect decreases as the distance increases. Therefore, powerful is ortho, then comes the meta, then comes the para, then comes the ordinary phenol. This is a simple effect where I said minus I is dominating on the plus M, which is a exceptional quality, not as an ordinary one. But if you plus M, if you remove on based on minus I, any student can easily arrange them. Then let us take another type of the phenols, that is the nitro substituted phenols. Nitrophenols. In the nitrophenols also you can take the 4 different phenols. One ordinary phenol, okay. Then we have a nitro attached phenol. Nitro attached phenol. Then we have a meta nitro phenol, that is the third one. Then let us have a para nitro phenol. Let us say A, B, C, D. Now, if you want to discuss the acidity of these three, nitro, what type of group it is, means it shows minus I, minus I, minus I. In all the 3 cases, minus I is there. And nitro is also going to show another feature. What is that? Electron withdraws through the bond as well as over the bond also. Through the bond, I said inductive effect. Over the bond means using the resonance also it will withdraw, which results in the at ortho position you will get a positive charge. Not only at ortho, it goes to the para to the nitro, ortho to the nitro. Therefore, one of the carbon where OH is attached, it is making positive charge. Therefore, it is going to withdraw electrons through the carbon, through the oxygen, then the proton is ejected, given out easily. So, therefore, the nitro is having 2 influences. One is minus I, the other one is minus M, right. So, all these nitro groups can show minus M on the benzene ring, but will it be helpful to use this one? Means this nitro will produce plus on the carbon, therefore influencing. This nitro produces a positive charge here and here and here. So, the carbon where OH is there, it is not influencing. The nitro is showing minus M, but it is not influencing on the carbon where OH attached. Therefore, this minus M you can take, it is not influencing. It is not influencing. Again, this is influencing. In this case, it is how it is far away. How can it influence? Means if this withdraws, the double bond comes, a positive charge comes, then this comes, a positive charge comes here, a positive charge comes. So, a carbon where OH is there, it is becoming positive charge. So, therefore, nitro group at ortho and at para is influencing the carbon where OH attached. So, when only at meta is not influencing, this is influencing. So, both are negative only. It's a wonderful double effect will come. So, you when add up also negative effect, this also negative effect only, there is no positive to cancel. All will have a additional factors are minus I only, but in this case only single effect, in this case double effect. Therefore, B, C, D, you can state 1.1. All the B, C, D are stronger than A because nitro group shows minus I, therefore B, C, D are stronger. Among the B, C, D, then you can B and D, that is orthonitro, paranitro, are stronger. B and D are stronger. B and D are stronger than the C because C is showing single influence, B and D are showing double influence. So, you can say that ortho and paranitrophenol are stronger than the metanitrophenol. This is one important point. Among the B and D, there is also again there is a dispute. What is that? Mesomeric effect, whether it is ortho or para, is equal. This M is equal. But minus I is not equal. Minus I closer means stronger. Okay. This is a medium type. This is a weak effect. Strong, weak and medium type. Anyhow, it is out of the comparison now. Among the B and D, inductive closer strong effect will be there. Inductive far away weak effect. Therefore, based on this particular issue, what we guess is B must be the stronger than the D because it is minus I is closer, therefore stronger effect. What is found is reverse exactly. The D is stronger than the B. How come it is? Means this hydrogen, the double bond O polarizes and gets a delta negative. So, H will have a delta positive. This plus and minus will have a bond called hydrogen bonding. What is hydrogen bonding? Just hydrogen involved is not hydrogen. Hydrogen attached to oxygen, nitrogen, fluorine. Whenever it is attached, the hydrogen becomes a more delta positive. Then such a delta positive neighboring delta minus or full minus, it makes a little stronger attraction, that is specifically called hydrogen bonding. So, because of that, how acidity is going to be changed means, what is acidity? To cut this hydrogen and take away, right? When this oxygen also connected, you have to cut one more. Anyhow, you need some energy to cut here. Now, if extra cut you need, that means the difficult to come. So, the hydrogen which is there in the hydrogen bonding with nitro is having a problem of coming out. That means acidity is decreased. This is called by virtue of this the ortho it is making, isn't it? Ortho position nitro alone makes, meta and para cannot make. So, by virtue of the ortho position, nitro is making hydrogen bonding as well as one more also. If a base want to come from here, let us say, and take the proton, it is easy. But a base coming from this side, a nitro group will be on the way, isn't it? So, therefore, base cannot approach the proton. So, certain directions it is blocking, that is called steric hindrance. So, the nitro group by virtue of ortho position is doing two things. One is it is making hydrogen bonding and not allowing the proton to go out. It is blocking the base to obstruct this proton, so not allowing to grow the proton. So, both these two phenomena, that is, one is by intramolecular hydrogen bonding, it is within the bond, isn't it? Intramolecular hydrogen bonding. Intramolecular hydrogen bonding. And another feature is a steric hindrance. Both are decreasing only. Fortunately, both are decreasing the effect of acidity, and together both are by virtue of ortho position. So, you can claim both these two effects together as ortho effect. Ortho effect. The ortho effect is not actually, it is not decreasing acidity, not increasing basicity or something like that. Any property changed by a group, by virtue of if any group, if it is ortho, it influences this group, isn't it? All such effects together you can call it as a ortho effect. So, this nitro is producing an ortho effect and the decreasing the acidity of OH by means of two internal, the small different aspects. One is intramolecular hydrogen bonding, the other one is steric hindrance. Therefore, B is the, isn't it, weaker one than the D. Already decided out of the B and C, C is single effect, B and D. I expect actually B should be the stronger because strong minus I, but what is the data shows that D is stronger. So therefore, D is third effect influence is D is stronger than the B. So ultimately what comes out is the D, the para-nitrophenol will be the stronger than the B. Both are double influencing over a single influenced that is metanitrophenol over a ordinary phenol. So the answer is here, or the overall order is para-nitrophenol is the stronger one over orthonitrophenol over metanitrophenol over ordinary phenol. All nitrophenols are stronger than ordinary phenol. Among the ortho, para, meta, meta is weaker and ortho and para is stronger, double effects. Out of D and B, B has a specific observation, that is ortho effect. Due to the intramolecular hydrogen bonding and steric hindrance, the acidity is decreased. Therefore, this finally resulted like this. Here we are using inductive effect, resonance or resonance effect, mesomeric effect, and also the steric hindrance also. See, hydrogen bonding is also coming, however, but this all these effects together we are applying in a nutshell and then saying this particular order, isn't it? Right. So let us have a examination of another set of phenols, that is a OCH3, that is a methoxy group containing phenols. Methoxy phenols. This makes another type of the example. Here you can take hydroxy, amino, similar groups works out the same type. So here also you can take the 4 phenols. One is ordinary phenol, right? The second one is methoxy group at ortho position, orthomethoxy phenol. Then metamethoxy phenol and paramethoxy phenol. So now first of all, what type of this group, methoxy group? Will it increases or decreases, or in turn what effects it will show? Through the bond, oxygen will withdraw the electron. Therefore, all these three shows minus I, minus I, minus I. This minus I is not there on the phenol, ordinary one. So because of the minus I, the acidity of the phenol should increase, because the OCH3 is pulling the electron density through the bond, through the bond, through the bond, through the bond. It reaches the proton. Little far away, but it acts. Then the over the bond, that is what the lone pair of the O may be donated like this, and this may be donated. You will get a carbon on which OH attached may become a minus charge. In the previous case, it was becoming a, in the nitrophenols, this carbon is becoming plus. Now this effect is reverse. It is called what? Plus M effect. Electron donating mesomeric effect. All three can show that lone pair donation effect, right? Plus M, plus M, plus M. Will all this minus I influence equally? Naturally, minus I closure will be the stronger one. This is medium one. This is weaker one. Okay. So the all minus I will not be same. As the distance increases, the effect nullifies or cancels by way of distance, therefore decreases. This shows small, weak effect, medium, strong effect. Will the all plus M effects will be working same means, first of all, see here OCH3 donating. So the carbon where OH is becoming a negative charge. Whereas here, if this donates, the double bond becomes this minus and this minus and this minus. So, the OCH3 can influence the benzene ring at ortho to OCH3, ortho to OCH3 para. So, the carbon where OH attached is not at all influenced by the plus M effect. Therefore, let us round it off and say not influencing, not influencing. You may say it is working, why not influencing? That is a wonderful question. In fact, it is working on the benzene. The OCH3 is not silent, it is working and showing plus M effect on the benzene, but on wrong position it is showing. That is called a position factor. In fact, the OCH3 showing a mesomeric effect and results a ortho para ortho only, but not the carbon. Okay. A student, like for example, tomorrow exam is there. If he reads well, he will get good marks. But if he reads mathematics and exam is chemistry, will he get marks? No. So, the effort is doing, but it is becoming waste, because on a wrong direction it is going. On the carbon where OH is there, it is not in. That is why we said not influencing. Whereas here it is influencing, because its minus charge reaches here and reaches on the carbon, also reaches on the ortho. So, one of the carbon where OH is attached is influencing. It is far away, but influencing. So, both are influencing, this is not influencing. If we add up the factors, why should I add? Means one is minus, one is plus, it is a must, I have to add. And here, as I said, always a mesomeric effect, whether it is plus or minus, dominates over the inductive effect, right. However, mesomeric effect dominates over the hyperconjugation, which dominates over the inductive effect. So, inductive effect is the weaker one. Only these two, again mesomeric effect is dominating. In general, that is all. Exceptions may be allowed in here and there. So, in general, mesomeric effect is dominating. So, therefore, what comes out of net? Net comes plus comes. Here nothing, zero effect. Here comes plus effect. Here plus is not there. What will be the net? Minus effect. Again plus and minus. Plus is the dominating. You have to add up. When one showing group showing two controversing features, minus I and plus M, which will be the net? Means always plus M. Mesomeric effect dominates over the inductive effect, except in the case of chlorophenols and the activating property of the chlorine. Always the mesomeric effect dominates. So, therefore, the plus M effect is dominating over the I, therefore, net is plus, net is plus. Now, you discuss a ordinary phenol is there, a phenol with withdrawing group is there, a phenols, two phenols with donating is there. So, definitely what comes, if I say A, B, C, D, label them, then C will be the stronger, because minus group is there. C is stronger than A, B and D, because C has a minus group, isn't it? And 0 is better than the plus M. In among these three, 0 is better. So, A is better than the B and D also. This is also another factor. So, second order is first we said minus groups are strong acids, therefore, I clarified. Then among the A, B, D, A is a 0. 0 is better than the donating groups. So, donating group decreases the basicity. So, these two donating, this is 0. So, I said A is better than B and D. Then among the B and D, now again there is a small dispute. B OCH3 is close minus I. Mesomeric effect is equal. This mesomeric effect is equal. There is no distance factor. Only what should persist is conjugation. Yes, this is also in conjugation, this is also in conjugation. Same effect will be there. So many single double. If the conjugation exists for a longer distance, the effect on the first carbon and the last carbon will be same, provided in between conjugation sustained. So, therefore, the same plus M equal these two, but the minus I is stronger. Therefore, this should be the stronger than this one. In the previous case, we expected that, but it went on wrong, isn't it? But in this case there is small difference. The OCH3 cannot make hydrogen bonding. Why cannot make? There is a hydrogen. There is a hydrogen is there on the O, but this oxygen is not enough minus charge. Oxygen to carbon, oxygen to carbon. There is no enough minus charge, so that the minus charge attracts. Neither these hydrogens have no positive charge. If this oxygen is there, in fact the oxygen where hydrogen attached, the phenolic O has got enough minus, but unfortunately hydrogens attached to carbon is neutral. So this way or that way it is a failure one. So therefore OCH3 cannot make hydrogen bonding. Only it can produce is what? Steric hindrance, only steric hindrance. So this try to decrease the acidity of the OH through only steric hindrance, and this is not able to topple the idea that is minus I strong and weak. So therefore as such it is existing. So it is said that B is stronger than the D. It is what you expect is observed also same. So final order what comes is, that is metamethoxy is the C is the strongest one over the A, that is ordinary phenol, over these two ortho and para. Out of the ortho and para, ortho is stronger than the para. Para is D. So this is the final order, that is ordinary phenol is in the center now. Metamethoxy happens to be the strongest acid. Actually methoxy is a plus M group, but plus M is not influencing, minus I comes as a net influencing effect. So therefore the methoxy at para position, amino at para position, hydroxy at para position is found to be the stronger acids than the corresponding substituted phenol. So finally what we want to say is metamethoxy phenol is stronger than ordinary phenol, then orthophenol, then para methoxy phenol. That is the final order.